Okay, good evening to everyone watching. Welcome to IEEE's flagship event, Insight 2020. This is the Diode SIG. Today, so let me start with introducing the event. Insight is an event hosted by IEEE every year where seniors, to be precise, final years, share their experiences and their journey in getting placed in various companies as well as internships. They also share various experiences of creating MNCs and handling their education along with co-curricular activities. So this year we have 5 speakers who will be sharing their experiences and tips and tricks to the juniors. I think we can start. I'd like to introduce just the 5 speakers. So today our speakers will be Shivam Poddar, Diksha MS, Naman Agarwal, Rohit Yadgiri, and Manas Sharma. All 5 are finalists from our institute and have various accomplishments under their name. So I'd like to welcome all of them. So welcome, guys. Okay, so let's move on to the first speaker. First speaker is Shivam Poddar. He is from the Electrical and Electronics Engineering department at NITK. Currently, he is a research intern at CAD Labs, Supercomputing Education and Research Center at IASC Bangalore. He is also a recipient of the he has also participated in Google Summer of Code and Open Source Silicon Foundation in the year summer of 2020, and is also an intern at Vadhwani Electronics Lab at IIT Bombay. Currently, he is placed at Samsung Semiconductor India Research and Division. So I'd like to hand it over to Shivam. Shivam, you can go ahead.
Hello everyone, I hope my video and audio both are fine. Aditya, can you hear me?
Yeah, go ahead, Shivam.
Okay, cool. I'll share the screen then. Right. Let me know when you see the screen.
Yes, it's visible.
Great. And now the camera as well, I hope. Okay. Right. So, hello everyone. I am Shivam Poddar. I think Aditya introduced me quite in detail already. First of all, I'd like to thank IEEE and ITK for organizing this event, and I'll welcome everyone who is here since I'm the first speaker. So, the title of my talk I have kept as Hacking Your Career. Why this particular word, will come to that. Let's get started then. So this is the brief agenda which we are going to follow. A short introduction, which is kind of not needed now since Aditya has told a lot already. Then we'll go over, in short over about the areas that we have in WE and EC, just to give you an idea of what all technical areas are there. And then in brief, I'll give you a journey in terms of my every year here in NITK, and then we'll spend a few minutes over just the career options, and then some general tips. Right. So about the topic, right? Why hacking? So in this context, hacking has 3 meanings. One is being able to manage successfully, which you will do with your NITK life. Second is a good solution or piece of advice. That is what Insight is meant for, and you'll obviously get a lot of this today. And third is intruding computers and hardware, which is sort of my favorite. Right, so this doesn't have to be repeated. It's just pictures of some buildings I'm related to, the places I worked at or I'm going to work at. Unfortunately, Google Summer of Code doesn't have a physical building. And throughout this presentation, you'll see a lot of pictures. I've tried to make this a bit entertaining because all you're going to see is, PPTs throughout these 4 years. So hopefully this will be a bit more entertaining than that. So this part is already, as told by Aditya, I'm placed at Samsung Semiconductor, where I'll be joining next year. I'm currently working for my BTech major project as well as internship in ISC. I did GSOC with the FOSSI Foundation in this summer, and after my second year, I worked with IIT Bombay again as a summer intern. So I think most of the other things are clear here. I'll just give a short introduction to GSOC in case some people are not aware of it. So basically, this is a program which is organized by Google Open Source directly from their California office, and it is always a remote program. What they do is over a period of 3 months, there are certain open source organizations which first apply with Google with their projects, and then students can apply to these projects. They can pitch in their ideas and then work on these projects throughout the summer. So that's how it basically works. And every year, like thousands of people apply, a few get in, and it's really a great opportunity. Right. So a short part about who am I in NITK. So I finished 159 of my 170 credits in 3 years, which is basically the entire coursework and lab work. Like all I have left in my final year is just the major project. I obviously to do this I had to take courses outside EEE as well. I'll go over it like what all courses I took. So that was from EEE, EC, CSE, and CSD. My current CGPA is 8.62 after the end of seventh semester, and the clubs that I'm part of is ACM Flying and Robotics Club, IRIS, through which you probably signed into NITK and submitted all your documents and stuff. And Tech Nights is a committee which works during our technical fest called Engineer. Right. So let's go, over a brief background of EEE and EC. In short, we'll just cover what all, research areas are there, or in general, the technical areas that are under these branches. So in EEE, there are majorly four such areas. One is power electronics, which is basically, about conversion of electric energy, and in a new way, like you use semiconductors to control electric power and energy. And obviously, because the scale at which you're dealing with stuff is much higher than say small scale DC appliances, so there are certain special concepts there which you have to learn. Then power systems is something with which probably electrical engineering started. It's all right from generation of electrical power down to its distribution in your houses. Signal processing is mainly mathematical field, and it's like it is a very basic idea which then extends to a lot of other fields such as machine learning, audio processing, etc. And control systems is used in various fields like robotics, for instance, industrial control, etc. And how this works is throughout at least your first 3 years, you will get introduced to a lot of these subjects, in many cases through mandatory courses. Otherwise, if you're interested, there will always be advanced courses in the same domain, and you can opt for them and learn more according to your interest. About EC, there are majorly three fields. One is VLSI, then which is all about processors, chips, IC design, etc., which probably was the first thing that EC started with. Then communication, which is all about obviously the communication networks, Wi-Fi, 5G, 6G. These are the things which communication engineers work on. Then there is signal processing and machine learning, which is maybe one of the newest but the hottest fields these days, because there are a lot of people you'll find who are applying machine learning somewhere in their research or their industry problems. And there's a very good chance that throughout your journey in NITK, at some point you'll obviously be introduced to machine learning. Right. So this is the journey part, and I'll add a few points here that this is not supposed to be a presentation of my CV that you can always find online anywhere. How I've structured this is it is divided year-wise chronologically. I have just highlighted like 5 to 6 points every year which contributed to what I am today, which I consider as stepping stones to reach where I am. Obviously, you don't have to follow the same. Everyone has their own journey. Like all the other people on the panel also have their own story with which they reached here. But the point of telling you about this journey and the background behind it is just to inspire you to see that how diverse you can make your choices, how you can try out the multiple areas that exist, and then finally settle with one. So you don't have to like follow this journey as such. but just take inspiration from it, and wherever you feel like, just post questions if you want to know in detail, because I'll be just I won't be going into depth of any particular topic as such. In case you're interested in learning more about any of these, just let me know through the chat. Right. So starting with first year, you can take this as a reference for anyone in, say, circuit branches, or at least in EE and DC. These are the basic topics that I learned. One is C and Python. C is obviously an NITK course. I think at least half of you would be having it in this semester. Linux is a framework for operating systems. The most common one is Ubuntu. It is great if you learn it as soon as possible, because that will be very handy throughout your career. And especially in circuit branches, Linux is always used at one or the other place. So it's really great to have that background. LaTeX is a typesetting software which basically levels up your presentation skills, I would say. And again, that is something I would recommend, that learn it in first year, and as soon as you get the opportunity, maybe through your course assignments or some presentations that you have to give, just start using LaTeX and get a hang of it, because that will be really useful. In fact, as far as I'm aware, in EC department, at least in some courses, you will be in fact mandatorily made to use LaTeX. So if you know it beforehand, it will be always better. Arduino and NodeMCU are two circuit boards. They are kind of starter platforms for the world of electronics, hello world as we call it. And that is also something which you can easily learn in the first year with online resources, and that will give you a good head start, to other topics in electrical and DC. Then I got an opportunity to join Tech Nights in my first year. Generally, they recruit only in second year, but incidentally, in my first year, I was a part of the attendees in the Insight event, and the convener of Tech Nights was one of the speakers there. So he told about what Tech Nights is, what they work on, etc. And I then just asked him if I can join, and fortunately he agreed. So that is again one point which you should focus on, that if you feel that something is cool, if you want to know more about it, just catch that person and try to ask. It doesn't matter if they don't reply you, or if the reply is not positive. At least you'll be happy that you tried, and it will be always great if you get a positive response. And obviously the first year is the best time to explore. You'll make new friends, you'll meet seniors like us. Hopefully you'll be back in campus very soon, so you can look at other things like Mangalore Manipal nearby, our fests, which will hopefully start in the next semester. And more importantly, get yourself informed about the institute, the departments that are here. That is important, because at least for your batch, you have this option of minors, right? So after you finish your first year, you're supposed to have a choice about which. I mean, it's an optional thing, but you can always pick a extra field, and that gets added to your degree. So it can be something like BTech in mechanical engineering with minors in CSE, for example, or for say in management if you're interested. So if you spend your first year in knowing about all these departments, by the time you reach that stage where you have to make this choice, you'll be very well informed, and that will help you a lot in making an informed decision. So as I said, there will always be pictures from every phase. This is the board for this project. That is the TechNight Smart display that you see in the bottom corner. So I just got to work on soldering this board. Even that in itself was a great experience, working with these guys, because all of them were my seniors. So I learned some of the other things. Then these two are the Arduino and NodeMCU boards that I mentioned, and you can easily get them anywhere, maybe online, or even in brick and mortar stores. You can in fact get it as soon as possible and start learning it. So this is from my summer mentorship program with ACM. This is something that almost all of the technical clubs in NITK would organize in your summer holidays. So keep an eye on that, and if you get a chance, do participate, because there are a lot of diverse areas which are covered in this SMP, summer mentorship program, and you'll get to learn a lot through that. Yeah, so coming to the second year, I joined ACM and IRIS. That's how it works generally. Like most of the clubs, you'll get the chance to join them in the second year. In ACM, again, as I said, if I participate in an SMP, I get to know about the club, like what is the kind of crowd that is in that club, what kind of projects they work on. You can interact with the seniors of that particular club, and if you perform well in the SMP, that obviously gives you a better edge when you go for the club interviews. And I specifically joined Iris to get some management experience because as I was from electrical background, but I wanted to try out all the fields so that I can, later make a good decision about what I choose. That's why I joined Iris. Then I won a coding hackathon based on again Python, C, and Arduino. So more than the fact that I won this hackathon, the thing which you should take home from here is I learned it in the first year. I used it somewhere in the second year. So that's how it should be. Like you keep learning something, that you keep using it, then it helps you down the line somewhere. Then I did an industrial training in my December holidays on transformers. So because Arduino embedded, all that is sort of something in EC background. So I did this in transformers just to get some background on core electrical as well. And that was the main motivation behind it. I participated in something called as Yantra Robotics competition. This is also a really great opportunity. You'll get a lot of hands-on experience. I highly recommend it. I think it will be announced somewhere after September normally. Next year, I'm not sure if they'll delay it or what, but just keep an eye on that because that's a really great platform. How it works is they send you actual hardware kits. They ship it from IIT Bombay to your campus, and you can make a team and work on these projects. You're actually taught all those topics that are required for building your project, and then there is a competition of sorts throughout India. So that's really great to learn a few things hands-on. Then also in my second year, I got to take this course outside the AAA department, which is called Open Source Virtual Instrumentation. This is in CSD, which is an interdisciplinary lab in our college. And I think once you go back to campus, you'll definitely have at least a visit to CSD because that's probably one of the newest and most advanced labs we have. And it's not restricted to any branch. That is the best thing about it. And there are various facilities such as like 3D printing, laser cutting, etc. And also in my second year before the summer, I applied for a summer internship at IIT Bombay. Usually, how this works is there are programs called, such as IES SRFP. I think some of the other speakers have actually went through this program, so you'll get to know better about that. And anyways, even if you don't get in through the programs, you can always manually mail those professors, which is called as cold mailing. You actually go to the IIT's website, you look through the professor's profile, and based on what you have learned or what you have done throughout your 2 years, you can ask them to give you an opportunity for internship. So again, these are some pictures from the second year. This is something that you get once you join the club. Hopefully, you guys will get to see this as well in your second year. Then this is the bot which we made in the Yantra competition, the one on the bottom. And as you can see, all the chassis and everything, we actually got it made through CSD. So you actually get all these facilities, and all the hardware was sent by IIT Bombay. And these two pictures are from the Tech Nights project. So this is the strongman game. You would have seen it in malls or something, that you take an hammer, you bang it on this platform, and based on your strength, it basically lights up those LEDs. So all this was built from scratch as a Tech Nights project. And this was on display in the Tech Fest, obviously. So these are 2 or 3 pictures from IIT Bombay where I went in my summer. I got to learn about something called as FPGAs, which is, in short, I would say a programmatic way of writing hardware. So how it works is basically you write some code and it gets converted to actual logic gates on a physical device. So I'll just say this for now. If you're interested, you can Google and learn more about it. Then coming to the third year, I took my first 2 courses from EC, one in 5th sem and one in the 6th sem. So embedded systems was really great. It is in fact one of the most practical courses that I have ever had in NITK. It was mostly project based, and even in the exams we had very practical questions. Then I made my first open source contribution, especially in hardware domain in my third year, in something called as Hacktoberfest. It is a month-long event in October every year where you can contribute to any open source project. And if you make 4 contributions, basically you are given a T-shirt by an organization called DigitalOcean. And specifically in that, there was this lab from IIT Bombay called Yantra which participated, and I got an opportunity to contribute there. Then I also tried machine learning because that is something which many people talk about. I didn't have much background, So in the December after my fifth semester, we had this opportunity to take a winter school on machine learning in medical image analysis, and I participated there. I got some background on machine learning, and the satisfaction that I have seen this field as well. So that was again the motivation to see what machine learning is like hands-on. Then I got to publish my first research paper in my third year. Again, this is something that evolved from something I did before. So in second year, as I said, I took this OSPI course, and we worked on it even after that semester ended, even after the evaluation and everything was finished. And eventually, it turned into a research paper, which I presented in January of my third year. And also in my sixth semester, I took a course from CSE department. In fact, I didn't get credits for this because I already had this upper limit of 29 credits, I believe, for that semester. So I just took this for auditing, but it was again really great because I got to sit with these people and learn something new that was out of my coursework, you may say. And similarly, in third year, I again applied through email itself. I tried for some programs abroad, and I didn't get in. And parallelly, I was searching for professors in India as well. And because I had finished my 159 credits by the end of sixth semester, I could actually figure out a way to take off for my entire final year. This is not a very common thing. I doubt if it will be even possible with the new curriculum, which started a batch after us. But at least going for for 6 months is something that is very common, and many of you would definitely get that opportunity to do your major project outside NITK, maybe at say ISC, some IIT, or even outside India for that matter. So again, pictures here. This is from the paper presentation. This is from one presentation I gave for IRIS. This is actually the previous year's fresher batch. So we introduced them to what IRIS is in this place called LSCC Seminar Hall. Then this was me giving a KEP, which is basically knowledge exchange program on embedded systems to second years, I believe. And we again participated in Yantra robotics competition in third year as well. And the good part about this was even before my control systems course started in sixth sem, I learned a lot about it in the fifth sem because Yantra taught me all that to work on this project. So that's how things help. They do connect from somewhere, and they help you down the line. And this is the gift I received from the Yantra organization for the open source contribution. Right. So finally, final year featuring COVID-19 and Dalgona coffee. Back in March, I applied for Google Summer of Code. That's the usual timeline. I think you get the entire month of March for the applications, and somewhere in February you will get to know that which are the organizations that are participating. It's generally better to apply after your second year because you have background in at least some area, and based on that you can apply for GSOC because the general expectation there is you have some background in the project that you choose. You might be able to get in with no or little background, but that very much depends on the selection process. You can always try. And through GSOC I earned my first stipend because in research you usually don't get paid, and that was again a really great thing to earn some money in your final year itself. Then I got to present my first poster in an international conference, unfortunately virtual because of COVID. It was a conference called Design and Automation Conference in which is usually in the USA, but this time it was online. I attended many more because many conferences were free this time. Then I got placed at Samsung Semiconductor in February. And again, here my GSOC and ISC experience helped. In fact, the first technical interview that I had was majorly all about my projects. I don't even remember if I was asked, any of the syllabus questions per se. So the interviewer just looked at my CV. He saw that both ISC and GSOC is mentioned because I started ISC also in somewhere in June, and GSOC had already almost finished by the point I gave my interview. So he saw both these things in my CV, and majorly the interviewer wanted to know more, like what exactly have I worked on? Does this experience look real or whatever it is? So obviously your previous experience helps in interviews as well. And I got some teaching assistant experience as well with a educator in India called Kunal Ghosh. If you are in the VLSI domain, you will at some point get to know him. And I participated in 4 workshops with him as a TA, and I made many global connections thanks to GSOC. because like in my GSOC itself, I had three mentors. Two of them were from the USA and one was from Hungary. And apart from that, I got to interact with many other people, throughout the world. And there the highlight is that you should use platforms such as LinkedIn, Twitter, Reddit, Discord. There are many technical communities on these platforms, and regardless of your knowledge or experience level, they are always welcoming. And it is it is much above a forum. For example, if you ask a question on Quora, you really don't have the control on who will answer it, or it's maybe sometimes not very genuine. But on these platforms, people try to personally help you in some sense, and that is really great. And you should definitely try joining these platforms and making some connections. So again, pictures from final year. This is the first one is my poster which I presented at DAC. This one is the letterhead that you get from Google after you finish your GSOC project. This was some random day where I was working on the GSOC project. And this is the board which I'm currently working on at IISc. So if you noticed, the one in my after my second year at IITV was maybe 1/4 of this size, and this one is much more complex, much more costlier, and you can do a lot more on this in some sense. And so that's how things grow. Yeah, so this is my collection, I would say, as of now. All these boards are what I have in my room right now. Then some of them are at home, some of them are stuck in the campus. Yeah, so career options, I won't spend a lot of time because it is something that many of you would obviously know. I'm just listing out all the options that are here. I will tell about me specifically. I didn't intentionally apply to MS PhD this year because of the whole situation in the US. My primary preference was US. So possibly I might consider it after few years, but as of now, at least I have decided to join Samsung. And if you want to know maybe my opinion on one of these options, you can ask in the chat. Or otherwise, down the line, you will obviously get to know more about all of these options. Naman, in fact, will be talking about MS today since he applied for that and got selected. Then about startup, we have Manus. Industry, obviously, I told about my Samsung experience and so on. And again, in future, as you go through second year, third year, and so on, you'll get to know about other things specifically. So some general tips, which is the last section here. So talking about areas, like I mentioned, some 7 areas, including EE and EC. Which one do you choose? So here I quote, the Ghadi detergent powder that pehle istemal kare, fir vishwas kare. First try out, first use it yourself, and then believe that whether that field is actually good. Don't pursue something because your friends did it or someone says that it is cool. Just take up a project in that, take up a course in that, try it out on your own, and that is the only way to know if it suits you. See, even if your professor says that this area is good for you, that might not be the case, right? Unless you try it out, you don't know the actual thing. So try out everything that you feel is worth it. Then does GPA matter? That is true for maybe your university or employer, but essentially that's not the only factor. There are a lot of other things that go into consideration whenever you are evaluated, even for jobs or for MS or PhD admissions. So that is one of the factors, but not the only factor. You also need your experience and other things that you go along with. And for Sharmaji or for your neighbors or your classmates, no. Stop competing at this point. You have done a lot of it while preparing for JE. Now that makes no sense because all of your classmates also will have completely different backgrounds. For instance, Naman and I worked on the second year EANTAR project together, but after that we have branched off to completely different fields, right? But still, it doesn't make sense to compare our GPA with each other because our background is completely different. The areas which we are pursuing is completely different. Then about core versus software, if you are interested and if you think that you will be bound by your branch, then no. You can always try out on your own whatever you want. It's not that you get to learn everything from your courses or classes itself. There are plenty of resources online, and you can always learn it on your own. In fact, my whole portfolio, like what I'm working on currently, is somewhere in the intersection of EC and CSE, at least as per the NITK curriculum. So you can always learn something on your own and continue with it. And about knowledge, again I quote Baba Ranchod Das Chanchad that चारों तरफ ज्ञान बट रहा है जहाँ से मिले लपेट लो. Knowledge is being distributed in all directions. It's just about you to take it from wherever you want. So as I said already, there are plenty of resources online. You'll easily find it. Just search for the topic and learn it whenever you want. Again, about experience, it doesn't really matter if you're paid or not. If you're going to a startup or an MNC, all that matters is what work you do. Because if you look at my profile, I never went to industry for an internship, right? Like many people think that if you have a completely academic kind of profile, you would face some difficulty when you sit for job interviews, because they will kind of assume that you are going to go for masters or PhD. But then if my work is something that impresses that company, then I have a very great chance of getting in, and that's what worked for me. I never went for an industry internship. I didn't, in fact, didn't even sit for the campus internships in my third year. So as I said, all that matters is your work. If it is relevant, if you've actually done something great, it doesn't matter where you do it. And again, think out of the box. Always try to find out new ways. Always try to find new solutions, and that do something that your peers don't do. So that is always a fun thing to follow. So with that, we'll come to questions. I think I have few in the chat.
Yeah, thank you, Shivam, for sharing your experiences and tips. It was really informative, and I'm sure that it will be of great help to the students watching. So, there are a few questions from the chat on
Yes.
YouTube. So, for,
Have you sent all of them already? Okay, on YouTube there are more. Okay, I'll start from YouTube directly.
yeah.
Right. So first is from Ria. Okay. Can you name some useful websites or channels which we can follow? So it very much depends on the area that you pick. At least at this point, what I would recommend if you're a first year is, first of all, just search what all areas exist. Like I told about it in a very short description. So first get to know what all areas are there, and then you can specifically, as you pick some area, then particularly for that you will find several resources. Generally, if it is something that is partially at least part of your syllabus, NPTEL lectures are always good. NPTEL is a platform created by the IITs and ISC where professors from these institutes upload entire courses, and it is always free. So you can go to that platform and watch lectures there, or there are plenty of YouTube channels as well. And at least for some of the areas you will find Coursera courses. For example, machine learning is something where people generally follow Coursera first. So that very much depends on the area. I hope that answered the question. And Shantanu says resources to learn Linux. Uh, there is not as much to learn, I would say. See, how at least it worked for me is I started using Linux somewhere back in my class 7th, if I remember correctly. And it was just somewhere I read that there is this thing called Linux, which is like open source. You can do anything in the operating system. It's faster than Windows, etc., etc. So I just installed it on my system. I followed the guide on its website. The OS is called Ubuntu, so you can just go to its website. It will show you the steps to install. So install it on your system, start using it, and as and when you have to find something, just Google it out. There are plenty of forums where you'll always find answers. Like even at this point, even after using Linux for n years, there are still cases where I search something on Google and get to know about it, and it is new for me. So that's all about it. Like you just install it, start using it, and you'll obviously learn about it. Then Moha says, how do you practice learning hardware? Yeah, so for this, I recommend that get a board like Arduino, because it's fairly cheaper than say something like a Raspberry Pi, and there are plenty of resources available online. So you can get an entire Arduino kit, and you will find many of those YouTube channels where you can go and look particularly at projects or guides to work on Arduino, for instance. Then Shantanu says hardware organizations in GSOC. Okay, for this, I recommend that get a board like Arduino, because it's fairly cheaper than say something like a Raspberry Pi, and there are plenty of resources available online. So you can get an entire Arduino kit, and you will find many of those YouTube channels where you can Then Shantanu says hardware organizations in GSOC. Okay, for this particularly, Shantanu, I'll recommend you to go to my website. It's shivampodda.me. I'll type it out in the chat. So there, in this blogs section, you'll see a blog that I wrote during GSOC. So in that, I have actually mentioned a lot of organizations that are present. There are at least 7 to 8, if I remember correctly. All are in several different areas. So just go there and you'll find that as a good resource. Then Shantanu again says, is a master's degree necessary for VLSI? It depends, I would say, because generally, at least what I have seen, in jobs that are say posted online, they always prefer that you have a master's or 2 years experience. Like 2 years experience is somewhat standard in any company that I have seen. So, and like either 2 years experience or a master's degree. But what I feel is if you get an opportunity, if you say get a placement offer in your BTech itself in the VLSI industry, then maybe you should just go for it. And because obviously then it's, you'll spend same amount of time here, and instead of say the master's degree, you will get some industry experience. But that's a very individual choice, but this is what at least I feel. Then this question is, why did you not prefer masters over jobs? So this is, as I said, this is my current situation, because I didn't want to try for masters in middle of all this chaos, because it makes sense to do a degree like this when you are actually there in the lab. So that's why I thought that maybe this is probably not the right time, because we don't really know when the universities will open up as normal. Signal processing and machine learning scope. Yeah, so there is a lot of it. I think uh, uh, you will get to read or learn a lot about it later as well. And we have another speaker coming up who has essentially worked a lot in signal processing and machine learning specifically. So I think she'll be able to answer it even better than me. Then Danish says, when you say Linux, do you mean command line or a scripting language? See, so what I meant by Linux is the entire Linux-based OS. So, for example, Ubuntu, as I said, is the most common one. And once you start using that OS, then you will have to use things like Bash or the command line interface. You will at some point feel that using the command line is much easier than, say, the GUI in Ubuntu and so on. So that's like including all that. Experience with Iris. So in Iris, I was specifically in this team called the product team. It is into this field called product management, where you interact with the stakeholders, that all those who are related to Iris. That may be professors, deans, or including the developers from the Iris team itself. And how it works is, before they actually start coding something, you interact with them and the people who want your module, who want your feature on Iris, and then you chalk out a plan about how that is supposed to work. So that is managerial work, I would say, in some sense. Aditya says, how did you know what to learn and what not to learn? So I think I said this already, right? That there's no, definition of what is right for you. So as I said, I tried out many things because I didn't want to trust anyone saying, if that is someone says that machine learning is cool, I won't trust that guy unless I actually try it out myself. So that is, I think, the only way that once you feel that something, like, you will be in the situation when you have a topic, right? For example, say there's a topic called embedded systems. Now you're in the situation whether you should learn it or not. So you can obviously make that choice once you actually look at the topic. So take some course online, maybe go through half of it. By then you will know whether you're actually interested in it or not. So I think that's the only way to know for sure whether that area works for you. Okay, I think all caught up. Currently,
I think that was the last question.
okay. Yeah, and yeah, okay, just a sec. I have my contact details here. Oh, I left the slide. So when you go to campus, have fun as well, because this is not something you'll have again, not as much as BTech at least. And yeah, so these are my contact details. I would prefer that you maybe connect on LinkedIn. These slides are uploaded to my website. If you go to me, there's a talks tab at the top. You'll find PDF of this set of slides. Please see it. Right. Do we have any more questions, Aditya? Or all done?
I think that's all the questions
Okay.
from the viewers. So thank you so much, Shivam, for sharing your experiences. I'm sure it must have been helpful to all the people watching.
Thank you, Aditya. Thank you for having me.
Okay, so for the next speaker, we have Diksha MS, who's from the Electronics and Communications Department. Diksha is a summer intern at Spectrum Lab at the Electrical Engineering Department in IISc Bangalore. She's also a recipient of the Summer at EPFL 2020 fellowship, and she's also a full-time intern at EPFL Switzerland. So I'd like to invite Diksha to come and speak.
Thanks, Aditya. I'll share my screen and then start. All cool?
Yeah, Diksha, you can go ahead.
Camera 2, right?
No, the camera isn't visible.
Okay.
Yeah.
Now fine? Yeah. Good evening, everyone. I'm Diksha, and I'm the current final year EC undergraduate. So today I'll be talking about the NITK journey and the opportunities presented to me, achievements and mistakes, so that you can learn from me and work towards a research-oriented domain. So, sorry. So why research? I'm pretty sure there's a diverse audience out there, first, second, and third years. So let's start from scratch. So why research? I've heard from many people in the corporate field that it gets boring after a few years, that they do the same work every day, the same run-of-the-mill work. And I did not want to do that. I didn't see myself doing that and having a fun life. So the alternative presented to me was research. And why research? Why, to be more specific, it gives you a very flexible working times, a very flexible design, and you can explore multiple fields and choose finally. Like Shivam has stressed so many times that you need to explore a lot of things before finally deciding what you like. And I didn't want to stop doing this after my undergraduate. I wanted to continue exploring in the future as well. I want to do it, so that's why I choose this domain. And it also gives you an opportunity to gain in-depth knowledge comparatively in a better way and contributes significantly to your fields of interest. So, as a beginner or as an undergraduate, where can one do research? The starting point, obviously, is to work with the professors. Every professor in the NITK is a researcher, and they have some excellent work going on. And this is an easy way to start with. It's a beginner level, and of course, they have more intermediate and advanced level of research as well. Moving ahead, you can go work in IISc, IITs, IIITs, ICES, or national labs such as ISRO and Diode, which are the most famous ones. And there are other labs such as National Brain Research Center, NBRC, CDAC, which is Center for Development of Advanced Computing. These are well reputed and recognized even outside of India. Like I said, corporate 9 to 5 job isn't all that boring. There are some research and development labs, and they have pretty exciting work as well. So this is another place where you can do good research. And the most advanced I termed, because it's quite difficult to get, is universities and labs outside abroad. And it's very competitive because you'll be competing with the international audience, and you will need to be really good to get into one of these. So what does one need, or how do you what is needed to start off? Well, it's quite easy. You just need some passion and little experience, at least in this undergraduate level. In your first two and a half years, nothing much is expected. You show good interest and you have at least a couple of courses, and you're good to start with. So let's go back. Let's start with the first year. What did I do? And it's something that you can do as well. Definitely not the only way to do it. Apart from the courses, I participated in competitions and workshops conducted by the clubs. I explored Arduino, digital circuits, logical coding, and just made sure I know at least a little of everything that's going on in the EC. Well, it's important that you maintain a good CGPA in first year. This is because, it's going to be easy courses and a very chill time. It's not going to be hectic for you in your first year. It wasn't for our curriculum, at least. So maintain a good CGPA. Later on, when it gets more hectic, if the CGPA falls down, this CGPA will, the first year work will balance it out. Towards the end, there are multiple summer mentorship programs that will be available to you. And I took up image processing and audio processing because they sounded fancy to me, and I knew the seniors in the project. So it definitely was a good experience for me. And it was only good experience because participated actively. I did everything that was assigned, and this SMP can be a bad thing if you are not self-motivated. The other alternative to SMPs is taking up online courses. Given the digital transformation that we have had in the last few months, a plethora of resources is available, and it's definitely that's something you need to check out. And this is the first year. You are just out of the JEE curriculum, and you have had a freedom never known before. So enjoy your time. Pursue all the hobbies. I personally was a part of dance club, debate club, and I personally did a lot of art. I went on trips and I had loads of fun. I'm not sure about trips, but you guys can definitely pursue hobbies and blow some steam. In the meantime, it's necessary that you develop good professional speaking and writing skills. LaTeX, as Shiva mentioned, is an important thing because that's the standard expected in any corporate or any research domain. So, be it research or corporate, speaking and communicating is one thing that you should be very good at. If you can't talk properly, if you can't stress your point, or if you can't make yourself heard, well, it's not of use. You're not going to be seen, you're not going to be recognized. So make sure you have good speaking and writing skills, and so that you can shine. In summary, first year is all about exploring what college has got to offer you, and taking a small experience of everything. Coming to what I did not do, what are the mistakes that I did, and I hope you guys do not do it, is take up a technical project. While workshops and competitions give you a gist of what the field is, technical project is where you can really understand what the field is all about. I mean, you won't know all the workings of an Arduino by a workshop. Or I mean, workshop is also okay, talk is never sufficient, but if you do a project in it, you'll be thorough with it, and it's something that you can actually be proud of. I also did not do any summer internship, and well, it's not really a bad thing because first year internships are not that in depth. They are going to be superficial, especially under a professor. So if you intend to do an internship in first year to get a head start, go for a startup. They are more collaborative, they support you, and more encouraging, and a very good learning atmosphere. If not for anything, you can always go for online courses or work with professors in NITK, or work with the clubs of NITK. So there are options. NITK will give you loads of options to explore. Just make sure you do them. Coming to second year, this is the time you pick out the one or 3 to 4 or whatever you like, fields that you like, and you identify why you like them. Although it's going to be a very hectic schedule, second year is pretty much packed with courses and labs, so it's going to be very hectic. But despite all this, make sure you have a holistic profile, take part in workshops. My streaming is on. I'll continue. So everything's good, right? Screen sharing and video.
Yes, I think so. Let me just confirm it.
Okay.
Yes, Diksha, I can go ahead.
Okay, I'll start with what to do, and I'll continue with what to do in the second year. So it's going to be pretty hectic for every one of you. So even then, despite that, build a holistic profile and participate in workshops and talks conducted by the department and clubs. Let me tell you why this is important. This is going to be beyond your course structure. You're really going to understand know what's in the field. And in fact, I met my future internship guide in one of the talks. So you also build good connections in these workshops and events. So make sure you take part in them to know what's happening in the field. And I also strongly suggest you interact with the professors. What usually happens in a 50 minutes class is not enough for a professor to give out share what he knows. So his knowledge is much more. His or her knowledge is beyond class hour. So go back with questions, doubts, project ideas, and talk about his research, and maybe ask for a couple of projects and ask for internships. A professor has a lot of connections, and he or she can always help you get more internships and projects. In the extracurricular field, I joined IEEE NITK. I took up a couple of projects. I helped in the event management slightly, and it has been a great experience there. It's important I stress that the quality of projects is more important than the number of projects you do. Let's say you have 2 or 3 fields of interest, and doing one project in each field is more than sufficient. And beyond that, beyond 3 projects, it's going to be very slim. You're not going to learn anything in deep. So focus on learning things in deep rather than learning too many. You can always fill a resume with 5 projects, but it only matters how much you did in one project that will get you in your future applications. So where to do projects? Clubs, of course, but these are going to be self-motivated. Working under profs is a good idea. The professor can validate your work, and personal project is again a very self-motivated idea. In the summer of second year, I interned with Professor Chandrasekhar Seelamantula of Spectrum Lab at Indian Institute of Science, Bengaluru. So why? The courses of signals and systems and the projects that I did IEEE corroborated my liking for signals. It started, I think, with my summer mentorship on audio processing, and I knew that I like signal processing. So I took up this internship with Sir, and I worked on computational imaging. So it's a very less known field. Computational imaging is improving the resolution, of any image or any imaging. It could be starting from microscopy, lens, camera, or going up till MRI, CT, X-ray. All of these come under imaging. Anything getting a 2D image, 2D or 3D images, computational imaging. And these days, the fancy high resolution images that you get in camera all have algorithms, and it comes down to signal processing and numerical analysis. So my project was on an algorithm called Fourier typography, and I worked on improving the resolution of microscope computationally. So more about this field, maybe you contact me later, but I'll talk about how you get this and how I got this internship. It was cold mailing. I mailed the professor. He replied back with a problem statement which I had to solve. I solved and sent it back, and he finally gave me the offer. So this is a standard procedure. Usually it's a task or an interview that you have with the professor. So when you mail, what is cold mailing basically? So you write a mail, say, hey, sir, I like your work and I have these courses and this project in this field. Please consider my profile. Well, of course, not phrased this way, but at the gist, this is what you say. And if the professor likes your work and sees potential in you, he'll contact you back. So what's the takeaway from my internship? I barely had any good experience in the field. I only had 2 courses to validate my potential and one personal project. So passion is what you need. If you are passionate enough and show good interest with strong basics, it's good enough to bag an internship. And while in internship, make sure you ask loads of questions. While you can work by all yourself, Googling, it's not same as working in a team. Talk to your peers, talk to your guide and mentors, and of course the professor, and make sure you build good connections along the way of learning more. Coming to the regrets of my second year, what I did not do, and boy, there are many. So I did not apply to IIL Summer Research Fellowship Program. Very honestly, I did apply with 2 days of efforts into it, and I regret it. It is one of the accredited and reputed programs in India, and I suggest every first year to look for this in the upcoming year if you're interested in research program or not. It's always a good exposure to work under one of the professors. I also did not have any tangible achievements. By tangible, I mean something that I can put under the awards and honors section. And while learning should be your first primary focus, it's good to have achievements that say, yes, she is indeed good in this. So you can do this by participating and winning hackathons, ideation programs, and publishing the work that you do. Well, if not in a good conference, go ahead and publish it in GitHub repo and add the link in your resumes. In this way, you can show that you have actually done work and it's not all talk. I also did not explore multiple fields. For some reason, I loved signal processing way too much to look into hardware. And right now, sitting in my final semester, I think I wish I had explored a little more of analog design because I seem to like it now. So do not restrict yourself to one field, how much ever you like it. Go and explore other fields just for the sake of it. And who knows, one day you might actually like to skip to the new field, I mean. So now you have explored and identified what you like. In third year, it's time you improve the field you actually love. So it starts with taking in more in-depth electives. Take up more courses that you know will be doing in at least the near future, and make sure you put in good efforts there. In my case, I took up the winter school for ML for medical imaging. Shivam already mentioned it, and let me elaborate why I like this. So I never liked biology much, but on in this course we were introduced to the anatomy of brain. In fact, I even held a brain in my hand. I mean, we went to a hospital and stored brains, and we learned a lot about different neurological disorders, tumor anatomy, and a lot more. And 1 week was spent in learning x-rays, mris, ct scans, and we also learned a theory of deep learning and statistical analysis, I believe. And the second week was spent on the lab work. We were all the day or throughout the day in the lab. I think in 1 week we implemented 3 projects, and which is pretty good. The EC staff and the professors were very helpful, and I had an amazing time. And probably that is what introduced me to biomedical signal processing, and that's what I hope to do in the next few years. So, and it was all in 2 weeks. I got 4 credits in 2 weeks, and it's quite amazing, right? So make sure you grab these opportunities if they come in your way, maybe in the future, just for the sake of it, and just see, you might actually love it. In the extracurricular category, again, I did a lot of event management in IEEE and ITK, Engineer and Incident, which are the annual fests of NITK. So what made me do this? Well, event management is not just, all grunt work. You actually meet people, you learn from people, you interact with them. And in fact, in one of the events in IEEE, I was talking to my friends, and that's where I heard about EPFL Switzerland. Trust me, until this was just 2 weeks before the application program, and if I had not gone to that event, I probably would never have heard about this program. So go and participate and talk, and it will help you improve your managerial skills as well as your people skills. Coming to third year summer, and by the end of third year, it was I knew that I want to do a research internship abroad, and this was rooted in the reason that internships abroad has a very different work culture and much different from what we have in India, both qualitatively and quantitatively. So that's why I wanted to apply there. The first 4 ones, my tax for Canada, DADVOICE for Germany, USC Viterbi program from University of Southern California, and SNBOS program for USA. SNBOS accepts for applications to any reputed university in US. So these 4 internships are highly competitive in those particular countries, but I wasn't accepted to it. So the ones that I had positive results are through cold mailing, of course. I got an internship under Professor Mark Davenport at Georgia Tech, and this was on computational imaging, and it would have been a different version of what I did in second year, but of course an extension to it. So if you are looking for cold mailing, I would suggest applying to CMU, Georgia Tech, UIUC, Johns Hopkins. All these people are welcome to Indians and usually take in interns. So that's where you can look at. I applied within India also as a backup because who knows what's going to happen. And well, I was right, wasn't I? So I applied for I got an internship under National Brain Research Center, Gurgaon, under Professor Pravat Mandal. This would have been an extension of my work in the winter course that I mentioned. I also had a course in acceptance by Professor Sriram Ganpati of IISc Bengaluru, and it was mostly on speech processing, an extension of my project in IEEE and NITK. So, you see that all my acceptances here are based on an experience that I've already had. So, it hasn't been very extensive. I had one experience in each of these fields, and I got an acceptance. And the final one is the Summer at EPFL Fellowship at Switzerland. Like I mentioned, I applied it in in just 2 weeks, but I put in good efforts there and I bagged it. But wait, everything was cancelled. Every one of the internships I mentioned were cancelled in the month of March, and I literally had nothing. But was it the end? The digital transformation of the world really happened very fast, and all of the work turned into remote. And I worked with Professor Martin Yagi of EPFL outside the fellowship. He offered it personally, and I'm still working with him for the past 8 months. For the 2 months in May and June, I also worked with Professor Pravat Mandal at NBRC in a simple work as compared to EPFL Switzerland. So what is Summer at EPFL, and what is EPFL, and how can you get it? EPFL is one of the two federal institutes of Switzerland, and hence very heavily funded. It is also ranked in the top 15 universities of the world. Their acceptance rate is less than 25 out of 1,000 applications worldwide, so it's extremely competitive. So how do you build a profile that fits into it? It's quite easy. In fact, it does not require much efforts. What I feel they look into the most is the class rank. I feel it matters a lot. Your CGPA is like the screening factor. It's not the deciding factor, but it's the screening factor. So if you have a high CGPA, you're going to the next stage of screening out. So what comes next is your resume. That is to say, what projects have you done in the past? In my experience, the Professor Martin works on machine learning and optimization mostly, and all my projects have been in this field, 2 or 3. So that's how you grab attention, and finally you make sure you get it through your letter of motivation. And this is something everyone gets wrong. What everyone focuses on doing is talking about their experience, their technical terms, and their technical knowledge, and this is not a letter of motivation. In letter of motivation, what you do is, well, as it says, you talk about your motivation, what motivates you, and why are you applying, and how is this going to help in your long-term and short-term goals. You also talk about the field of interest and why are you interested in the field. And like you just thread a story. You don't talk about technical terms, and talk more about your passion. So coming to the final year, which is the past 6 months, I extended my EPFL project to make it a SEM-off. I worked on it. I did 2-3 projects side by side, in the same place, while the final task was similar. And it was focused on applying deep learning and signal processing for biomedical applications, precisely diagnostic modeling of COVID-19. I used lung sounds from different position of the lungs, recorded using an electronic stethoscope, and we used different kinds of deep learning and statistical analysis to say if the patient has COVID or not. And we have pretty good results as well. So, and thanks to this is only because of an amazing team that we have back at EPFL. We have a very broad network of co-workers. I have met with people from Swiss, France, Spain, South Africa, Iran, China, and Pakistan. Well, and the team is so big that there are crossovers happening where I do implement a part of their project in my project, and they help me in more applications. So it's going to be a very collaborative work. Like I said, the work culture there is different from what we have in India. Crossovers is rare, but it's a routine there in EPFL. I was also given a lot of exposure. Our project was covered in the news and social media, and I'm also preparing for two, three publications. So I really didn't have any tangible achievements back in second year, but in 1 year, I have publications. I have made it to news, and I also have some to put under the awards and achievements. So what it really matters is that you have some passion. Once you have passion, you can do anything you want. In the extracurricular, like I try to stress everywhere in every other slide, I took up chairperson of IEEE NITK. This was only to keep me grounded and keep connected to my friends in the club and have good networking and organizational opportunities. So the final takeaways of my talk is higher the CGPA, the better. Well, it's not going to be the deciding factor, but it's going to open a lot more doors that it otherwise wouldn't have. Passion is all you need to begin. Even though by the end of second year, I didn't see myself in a big place, I have turned it only because I was hardworking and I applied to every opportunity that was presented to me. Be inquisitive and communicate. Ask a lot of questions. Make connections and make sure you're heard and not always silently accepting what your superiors or your friends say. Be proactive and take up a lot of projects and achieve whatever you want. Make tangible achievements. This is what I'm trying to say. It's only with good achievements to corroborate your knowledge is what is going to make you stand out. Make sure your work is out in the world and not sidelined. Another common thing that is usually done by people in India is not to aim high. What they do is take up simple things because they are easy. They take up lower ranked universities because they think that's going to guarantee them an admission. But you know your worth and you should aim higher. And well, you will get it. As long as you're diligent enough, you're going to get it. On a side note, you must pursue hobbies because that's the only thing that's going to keep you sane and have some fun. Extracurricular roles are also important to connect and build managerial and organizational skills and have lots of fun. This is the only time you're going to be with friends and enjoy. I'm not sure I can say with your online semesters, but go on trips once you come back to campus. And Mangalore and Udupi is going to offer you a lot of places to roam around, and Goa is not too far away. Thank you, everyone. Any questions?
Thank you so much, Diksha. Well, thanks for sharing your experiences and your views on pursuing research for a career. And students, especially those who are interested in research, will have a lot to take away from your talk. For questions, I have one question actually. Have you ever handled more than one research project simultaneously?
Yes.
And
So,
what are your views on trying to publish a paper before leaving colleges, as in the lower semesters?
you should. Okay. I am about the first part of the question. I did in the this summer of 2020. I was handling the EPFL and NBRC together. So it's going to be hectic. So the research demands for a lot of hard work. So do it. If it is in two different organizations, then probably do not do it. But if it is within NITK doing personal projects and under professors, it should be okay to handle it. And about publications, you must publish, even if it is a slight improvement from what is already in the literature. Even if it is a 1% increase from the recorded state of art accuracy, go publish it and give out your methodologies out to the world. It's fine, and it's valued in your applications to higher studies.
Okay, thank you so much.
Okay.
It seems there are no more questions. So thank you, Diksha. Thank you for sharing all your experiences. So I think we can move on to the next speaker now. Our next speaker is Raman Agarwal from the Electrical and Electronics Department at NITK. He's an intern at Power and Controls Department at Infineon Technologies, and he's an incoming graduate student at TU Delft at Netherlands. So Naman, take it forward.
Thank you, Aditya. Just give me a moment. Yeah, so is my screen visible?
Yes, Naman, you can go ahead.
Okay, just a moment. All right, welcome everyone to Insight 2020. So, uh, so my talk today is titled "More Power to You," and the reason for this title will become evident going forward. If you have any questions, I'd be happy to answer them at the end of the presentation. So please do type them out in chat. So the main agenda for this talk is going to be me reflecting over my journey over the last 3 years and how it's brought me to this point. And hopefully that will give you some idea of what you can do at college. So a quick intro about me. I'm finally a student of the IEEE department at NITK. And my technical interests lie in the power electronics domain. So just for some context, this domain is concerned with the conversion of electric energy from one form to other. And the best example I think I could give you about this is that of your laptop charger. So if you ever bothered to read the fine print at the back of your charger, you might have seen some text which looks like this. So it says 240 volt AC input and output of 18.5 volt DC. So this conversion is what power electronics deals with. It's electricity in different forms. And this is a field I'm very passionate about, and I hope to shed more light about to you guys. So coming into first year, I think the biggest conundrum most people have is what do you do and how do you start? So obviously you have to explore multiple fields as the previous speakers have pointed out. And great ways to do this are to take part in competitions, hackathons, and club events. So for instance, I took part in first year, I learned a lot about computer vision and Arduino programming and so on from the various club events organized. So we have 5 technical clubs on the campus, and they all have really insightful events throughout the year. And then in my second year, as Shiva mentioned earlier, I took part in the IEEE robotics competition. So that again really, broadened my view of what all is actually possible and gave me good insight into what I like and what I don't. Then in second year onwards, when you're actually studying your branch, there's a lot of small projects in your courses. So I would suggest you guys do these projects with conviction because they really teach you a lot about what the domain entails. And finally, your department that you are admitted to doesn't really matter because you are free to choose what you want to learn. But if you are interested in the department which you're a part of, I would highly suggest that you take the department mini project seriously in the second year of your study. So just for some background, each department offers 2 mini projects worth 2 credits each. And each mini project lasts for 1 semester. So a mini project is a great way to explore a branch related topic under the guidance of an experienced professor in your branch. So I did 2 mini projects, obviously, and they were really helpful because the first mini project I did was based on machine learning applications for wireless power transfer. And that really gave me an idea that I like the wireless power transfer more than the machine learning aspect of that project. And hence I decided to pursue in that direction, being power electronics. So you can approach profs who are in your area of interest and figure out what you like and what you don't once you get to go in depth. And the final tip I'd like to give you is have a learning oriented approach in college. And to do so, you have to snap out of the so-called JE mindset. So I think a lot of us coming in from these intense JE coachings are used to being spoon-fed material and content and being told what you should learn and how you should learn. So breaking out of that habit is important, and you need to exploit the freedom you have to learn. So you're free to learn anything you want now and just enjoy that freedom. Secondly, always keep in mind that the final results of any project or endeavor are irrelevant, and it's only what you learn and what you take away from them that matter. And I genuinely do not think anyone in college would ever care about the final results of your project, and neither should you. And most importantly, just don't do a lot of projects to make your CV look bigger. It's very easy to spot superficial projects, and it's a disingenuous way of representing your skills. So please don't indulge in such activities. So as I mentioned just now, the mini projects are really important. And doing the first mini project told me that I should pursue the power electronics domain more, because that is what I found interesting. So coming to that, so this is the second mini project I'm talking about. So I approached a professor in my 5th semester in the IEEE department who also works in the power electronics domain. And I worked through the project in the 5th and 6th semester, even though the mini project is offered only for 1 semester. So you can always work as much as you like in college. No one's going to restrict that. So what we worked on was actually developing a solar inverter system. So I think the best analogy I can give you for this is the UPS systems you have at home for power backup. So what happens is you have a battery which is charged from the mains. So what we developed here is a charger. So this charger PCB, which is highlighted in red, charges the battery, but instead of using the AC current from the sources, from the power source, it uses the DC current from the solar panels available. And once this battery is charged, it can be used in cases where there's a power cut. So for that, you need another inverter circuit, which is highlighted here in red. So using this again, like the UPS inverter system you have at home for power backup. So the DC power from the battery is converted to AC, which can be used by loads such as the incandescent bulb and any other thing in the household. So working on this project over 2 semesters was really important for me, both in terms of technical enlightenment and general knowledge about what the scope of the field is. And what you realize is that you don't really know anything at all. And I think that is very accurately represented by this Dunning-Kruger effect curve here. So here in this curve, you can see that the x-axis represents the competence or the knowledge you have in a field. It could be any given field. And the y-axis represents the self-confidence that you harbor regarding or with reference to that field. So initially, when you actually know nothing at all, you're at the peak of Mount Stupid. So you assume you know a lot, and then you can do a lot of things. But as you start learning more and more, you fall into the valley of despair and realize that you actually don't know anything. And I think the valley of despair is arguably the most fun place to be at, because it's just there that you truly realize what the scope and the beauty of the field is. And it's like at the start of a really long and uncertain journey that you're looking forward to. So I would recommend each one of you to actually experience this valley of despair at least once in your entire college time, because it gives you some good perspective and something to introspect about. So this project obviously was very useful technically, and what happened was the professor who I worked under was pleased with the work that I did. So he decided to recommend me to an industry contact, which led to the next step in my journey, which is the internship. So this internship actually just wrapped up a week ago, and it was for 6 months through the 7th semester of my studies at Infineon Technologies, Bangalore. So Infineon is a major player in the semiconductor and the power electronics domain. And it is at the back end of practically every consumer electronic and automobile product that you might have ever used. So for context, So 6 months off is basically a semester of project, and I think Shivam mentioned about this before. So it can be either at a company or at institutes in India or abroad, and they require certain credits for you to actually opt into this option. And I would recommend you decide if you want to go for a semester off by your 5th semester, so that you can actually work on obtaining an opportunity by the 6th semester and have it all finalized and ready to go in the 7th semester, so you have no issues or confusions. And there are obviously several ways of obtaining one internship. I was referred by my prof, and as Diksha elaborated in her talk, cold mailing is another great option. So these are all points you should have at the back of your mind, especially if you're in the first or second year of your studies, so that don't think about it too much now, but going forward, just have it in your mind that there are certain opportunities available to you which are not on campus, and there's a lot for you to explore off campus. So coming to the work I did over the last 6 months and what it has taught me. So what we worked on, so this image here is a representation of the culmination of last 6 months of effort. So this is a power supply board, and I've just put in a photo of I just included this marker to give you a sense of scale. So I think a good way to explain the functioning of this board would be to use the laptop charger analogy. So your laptop charger takes in an input voltage of 240 volts AC, but this has an input of 320 to 1000 volts DC. And the laptop charger gives an output of 20 volts or so DC. This has 4 different outputs of varying voltage levels from 24 volts to 5 volts or 3.3 volts. So this isn't something that you would encounter in your day-to-day life. It has very specific industrial-based applications which I did not know existed till I actually went to this internship. So how do you actually go about making such a device or a product? So this is what I learned at the internship. This is the process. So first is the design and the simulation. So in such a big board, there are a bunch of small sub-circuits. So like there is one over here, and there's one over here, and so on. So you would design each sub-circuit separately and then simulate them individually to see that they're working properly. So once the design and the simulation verification are done, then you ensure that each aspect of that board works properly. Then you can finalize the design and move on to the component procurement. So this component procurement is a crucial part and a very tedious part of the entire process. So, and this is because each component plays a crucial role in the functioning of your board, and you have to get it right within the specifications, make sure it's available in the market, and it is within the budget that you're looking for. So there's a lot of aspects to balance here, and component procurement is easily one of the toughest tasks to carry out. Next comes the prototyping phase. This is when all your components are ready and you assemble the entire board. And we made 7 other such boards. So there's a total of 8 PCBs or power supplies. Once the assembly is done, you start with the exhaustive testing. So this is where you test each and every aspect of the device and make sure there's no part which can fail. And there's certain rigorous standards that you have to take care of to make sure that it can be deployed in an industrial environment safely and it won't fail under any given circumstances. And each aspect will perform according to the specific specifications. And then lastly comes the documentation. So documentation takes care of all the things that you've done. You have to mention what all you've done, what all you have changed during the design and prototyping phases, what components have been changed due to unavailability, and what changes you would propose going forward to improve the design. So, and this was a very technically enriching experience for me, and I would like to highlight some of the pros and cons that I took away from the last 6 months. So I think the first and the most important pro point is that you gain an immense amount of exposure to the scope of the technology that's being used. You learn about what all is possible in the industry and in the real world. You learn about new types of equipment and testing methods, and even about possible career opportunities that you could pursue going forward, since you're seeing all these people work around you on different things and you learn from them, and it gives you really good perspective on what you can go or what you can do going forward. The second thing you realize is that there's a vast gap between academia and industry. So what we study in college and what you learn through your courses means very, very little when it comes to developing something in the real world. And this really set me back to the valley of despair in the Dunning-Kruger curve that I highlighted earlier. And to really drive this point home, I'd like to share this example of a capacitor. So a capacitor is a seemingly simple device that you've been studying or using since your JEE or JEE questions and stuff. But in reality, when you actually have a practical capacitor, such as this one, and when you manufacture it, the internal circuit actually looks like something that I've highlighted on the right. And this is vastly different from what you assume to be two parallel lines. So incorporating this into your design and accounting for its effects is crucial, and it's not something you would ever encounter while studying this in college. So this is something we actually experienced in the project, and the capacitor we were using was giving us trouble. Like we couldn't figure out why the board wasn't working, and we finally it finally came down to the differential behavior of a capacitor, which is highlighted in this circuit because we didn't account for it. And yeah, that really throws your confidence in for a toss because you don't really know what to expect anymore. So those are the pros, but now coming to the cons which I realized of working in the power electronics industry in India. So there's a certain lack of freedom and scrutiny, and there's always some scrutiny, and I think this is true for any corporate job. You will always be expected to deliver and adhere to the timelines and the deadlines, and it always feels like there's someone watching you. The second thing I realized is that India is not a pioneer or innovator when it comes to technology, especially in the power electronics domain. And this was evident when I was there so there were a lot of internal workshops and blogs and newsletters and so on. And going through those, you realize that most of the innovation is actually taking place in Europe, China, and the United States. And that was a bit disheartening for me, honestly. And finally, there's not really much time or energy left at the end of the day for you to engage in your hobbies. So working 9 to 6 doesn't leave you with anything at the end of the day. And it was a real burden over the last 6 months, and it became really tiring towards the end, especially. So I'm genuinely surprised how people do this for the whole lives. So all of these experiences till now, so the many projects and the internship at Infineon have culminated to this point where I've decided to go forward with higher studies. So the mini project which I did led me to Infineon, and the mini project before that actually made me realize that I enjoy power electronics. And then working in Infineon made me realize that I should genuinely consider pursuing higher studies. So I've received an admit at Diode, Netherlands, and I plan on specializing in the electric vehicle domain when I'm studying there. So the reason for this is that I believe electric vehicle is obviously an up and coming technology, and a lot of and it correlates very well with the power electronics work that I've been doing up till now, and I'm genuinely excited to learn more about it. So the reason I decided to pursue masters, firstly, there's a lack of opportunities in the power electronics domain, and I think this is true for electrical branch as a whole. So there's very few industrial opportunities in India where you get to do meaningful work, which is directly correlated to the electrical domain. So it could be power systems, it could be power electronics, or even control systems and so on. So there is a real scarcity in India because they aren't developing technology. They're just using what's coming up from abroad. And as I mentioned earlier, there's practically no innovation in the indigenous tech, and whatever we are developing on our own is actually years behind the international norm. And obviously, going for higher studies will expose me to the new work culture and the different collaborative and innovative environments they have working there. So, higher studies is a really good option for someone who has core interests in a specific domain. So it's something that you should have at the back of your mind as an option going forward, but it is not something you should commit to. But generally, as you have it at the back of your mind, this is how you prepare for it. So you figure out the field that you genuinely enjoy. So to do this, you can do course-related projects, mini projects, internships, and so on. And really once you really know what you like, then you can develop some competence and experience in the field. So this is what the universities look at. They look at how much in depth you know in a specific field, and not rather how much of a breadth you can cover. So once you have significant experience, you can move forward with applying to higher studies. And when I mean significant experience, I mean something like an internship and maybe a major project, and that suffices. They don't expect much when you're applying straight away from BTech. So, and I would say do not succumb to peer pressure or family pressure and commit to a higher studies degree if you are unsure about it, or if you don't know which field you genuinely enjoy. Since it's a very large financial and professional commitment, I would say do not rush into it, and be sure when you actually do. And obviously talk to seniors. So seniors have the most recent experience and have gone through each one of the things that you have. So they'll be the best position to advise you and talk to you and relate to your feelings. So never hesitate to reach out to anyone. And finally, closing thoughts. This is a really important quote by Mark Twain that I've kept with me for several years now. So it says, "I've never let my schooling interfere with my education." And I think this drives home a crucial point of you're not ever restricted by your learning environment to actually figure out what you like and what you learn. Just keep on learning on the side and learning on your own, and don't let anyone dictate what you learn. So that brings me to the end of my presentation. Please feel free to reach out to me. Here's my phone, email, and LinkedIn IDs, and you can always scan this QR code to have these directly on the phone. So if there are any questions now, I'll be happy to answer.
Thank you so much, Naman. Yes, there is one question on chat. Studying in metallurgy and material engineering, is it difficult to get into semiconductor industries?
Certainly not. So essentially, when you boil down what semiconductors are, it is basically materials and material science. And I think that's a very niche and specialized field to be a part of. So I would definitely recommend you go forward with that if you're interested. But do keep in mind that I do not think there is a lot of opportunity for that in India. So you might have to look into opportunities abroad, either through a higher studies degree or through employment. But yeah, it is certainly a really specialized field to be in, and I would recommend you to pursue if you're genuinely interested. All right. So, any other questions?
Any questions? You can post it in chat.
Sure. If there's more questions, you guys can reach out to me on the contacts I've mentioned here. And yeah, if there's no other questions, I guess I can sign off.
Yeah, thank you, Naman. I really liked your explanation of how you face the Dunning-Kruger effect as you are pursuing power electronics, and yeah, it's really relatable, and I think students would better have a better idea of the opportunities available to them. So, thank you.
Yeah, thanks a lot, Aditya. Just one. There's a question in chat saying, "Can I become an NITK professor by getting 92% in class in 9th class?" Yeah, certainly. Only if you manage to reach PhD, then I don't think anyone cares. Once you have a PhD, you can do anything. All right. So I'll sign off now, and thanks.
Thank you, Naman. All right. So up next, our next speaker is Rohit Yadgiri. He is from the Electronics and Communication Department. He is a recipient of he's a summer intern at Spectrum Lab, Electrical Engineering Department at IIEC Bangalore, and he's also a summer intern at Samsung Semiconductors India, R&D, and currently he's placed at Qualcomm. So I'd like to invite him to share his experiences. Rohit.
Hi, is my audio and video fine?
Yes, I'll share your PPT just a second.
Sure.
Is the PPT visible? Yes.
Yeah. Just go to the full screen.
Yeah.
Okay, so I'll start. Okay. Yeah. So hi everyone, I'm Rohit Yadgiri and I'm from the EC department. I'm a final year and I'm here to talk about some of my experiences over the last few years, and I hope to touch down on some topics that I feel a lot of you have some uncertainty about maybe, and I'll try to my best to clarify them. So my points will mainly be from an EC point of view, but as you all know, EC and EEE have a lot of common aspects, so that should do as well. So can you go to the next slide? Okay. Some of the commonly explored fields. So I'm going to talk about that. I'm going to talk about some of the commonly explored fields and then the relevance of grades, how important is your GPA, and then I'm going to talk about second year internships, how to get them, and what was my experience with my internship after second year. And then I'm going to talk about electronics and programming. So a lot of people usually are confused being in EC and EEE, and should they code and should they do programming or not. I'm going to touch upon that. And then I'm going to talk about my third year internship and generally how the internship season is and how to approach it. And finally, I'm going to talk about placements, the placement season, as well as my own experience with placements and some other tips and tricks for the placement season. Yeah, so we'll go to the next slide. Yeah, some of the commonly explored fields among electronics and EC and EEE mainly are so basically core electronics. So that's the most common one. In core electronics, you have digital analog, system design, and computer architecture. So digital usually means you have so since your first year, you probably won't know a lot about it, but digital and analog are like the most common basic fields in electronics. And then there's computer architecture, which is like computer organization. And then you have embedded systems and robotics. So these are the most hardware-centric fields that you can think of, where most projects tend to be hardware projects. And if you know about our flagship event. It's engineer, and there's something called Tech Nights. It's an event in engineer where a lot of innovative projects take shape, and I think most of them are embedded system based projects, I feel. And then we have the new enigma of data or deep learning and data sciences. That is basically, you can think of machine learning, deep learning, computer vision, artificial intelligence, and all that. So this has really taken a lot of traction, has a lot of traction in the last decade, and a lot of people, even EC and triple people, are now focusing the attention on deep learning and data sciences. So this is something that people, you guys can check out. And then obviously we have software development. A lot of us end up looking at computer science fundamentals, programming, app development, web development, and there's so many other fields that I probably couldn't remember. So there are so many fields in software development that people explore. And finally, we have business management, economics, finance, and stuff. So actually, some of you might find it pretty puzzling that people explore these fields in engineering itself, but it's a very common thing, and people do it successfully, and this is something that you can all think of. Let's go to the next slide. So one more thing about exploring fields. So basically, there are so many fields, and what I would like to say is you are never limited by the branch that you have taken. So it doesn't matter what branch you are in, you can always explore whichever field you want to because of the online resources that are available everywhere, as well as you can always approach professors from any department in the campus. So you should never be limited by the branch that you are in, because your interest may not lie in the branch that you have taken already, and you can always make sure that you can find the right interest by exploring as many fields as possible. And by that I mean you try to explore as many fields as possible in a surface level, and finally when you get to know what field or what certain fields that you're interested in, and you can go deep and maybe do a project on it and get to know more about it, and then make a choice on what your career path might look like. So yeah, next is the grades. So how important is it to maintain good grades? How will that shape what I'm going to do in the future? So I would say that having essential skills with a low GPA is a better prospect for industry as well as academia, as compared to having no skills but a good GPA. But again, that does not mean you let your GPA go for a toss. I think it's very important to make sure that you have a conscious effort to make sure GPA is decent, because some people might say GPA doesn't matter at all. I feel that's not true. It does not mean you spend all your time in engineering trying to get a good GPA or be the highest GPA ever. But I think it's also equally important to make sure you have good skills on the fields that you are interested in. So optimally, you have a good skill set as well as maintain decent grades. I would say 8.5 plus is, or 8 to 8.5 plus is a very decent grade, and try to make sure that you don't let go for a toss. Very clear. So let me talk about second year internships in general. So when I talk about internships, you have some programs where you are assigned professors and you get stipend as well. And they're very precise programs like IAS. IAS is Indian Academy of Sciences. There's a summer fellowship program. So people usually apply for IAS in their second years. I think even third years can apply for that. And IAS basically consists of the IISc in Bangalore, and then you have all the IITs, and then you have triple ITs. So IAS, there are a lot of profs involved with IAS, and then once you apply using your SOP, that's a statement of purpose, and then your resume. So depending upon that, and I think CGPA plays a main role in IAS. You are assigned a professor which you can accept, and then you go and intern under the professor, which gives you a very good opportunity to learn a lot and get a lot of experience. And then you have Narendra Summer Internship Program, I think in IISc, Department of CSA. And this is a program that I know people who have gone, and I've heard it's a very good program to take a look at. Both of these programs, I think you have to try to apply them for them before by November or October of every year if you are interested. And obviously, the very common approach taken by most people is cold mailing. So cold mailing basically means you mail a professor, you don't know the professor before, and neither does he know you. So you just mail him with your proposal for an internship under him, giving your credentials like your resume and your SOP and why you're interested in the field and why you would really think that it is important for you. And if you do that and the professor really thinks that you can do a good job, he will probably test you by giving you a assignment, a small assignment, or maybe even take an interview. But that's usually how the cold mailing works, and a lot of people get accepted in this manner. Another tip for cold mailing is don't ever mail one professor and just wait for his reply. There's a very good chance that they won't even check your mail. So usually what people usually do is they mail like 25, 30 professors based on their fields of interest. So you go on different IITs, IISc, IIITs. So you go on and you check out different professors of different fields, and you check their work and see if that matches with whatever you do, and then you mail them with your proposal, and then they accept. So some of them reply to you, some of them don't. That should not bog you down. And finally, we have industrial internship, obviously. But usually, what happens is second years are commonly not interning in the industry. Usually, startups are the ones who take second years for internships. The next slide. So, how do you go about applying for internships? Again, I just told you. You first chalk out what fields you want to work on. So you have like some, maybe not just one, maybe 2 or 3 fields that you are interested in. Then you craft your SOP and your resume for each field. You make sure your statement of purpose is crisp as well as a resume. I know people who think that having a huge resume is a better resume, like you show that you have so much of work. But actually, in the industry as well as professors, no one reads the whole resume that you have. They don't have time for that. So they usually look at the highlighted points and the key points, and you should make sure that you write a resume as crisp and as brief as possible, but also highlighting what you've worked on so that they can get an idea of whether you are right for the job. And then, so once you have your SOP and resume ready, you apply for internships like fellowships like IAS or Anindra and all of those. And parallelly, as I said, you mail a lot of professors who you think are right for your field. Yeah, next. My second year internship was under the guidance of Dr. Chandrasekhar Silamantula. He is a professor at Spectrum Lab in Department of Electrical Engineering in IISc Bengaluru. And it was in May to July 2019 when I finished my 4th semester. And basically, I had mailed him asking for an internship in the field of signal processing, image processing, and stuff. And I got to work on neural network based approaches to perform denoising and superposition of images. So denoising, as in the input images has certain noise, and you're trying to make sure that you generate a crisper, cleaner image which is visually appealing, as well as have more information, maybe for a further experiment on the image, as well as super resolution, which means you have an image of a certain resolution and you want to increase the resolution without dropping the quality of the image. So that these are the two aspects that I've worked on. Yeah, so it was a very good experience in this field, and basically in your second year internship you should not look at stipend, because a lot of times you don't get paid, but that's not the most important thing in second year internship. It's more important that you make sure that you get a very good idea of whether the field is right for you and whether research is right for you. That's why I feel like in second year it's better to go for a research internship, because third year it's very common to take an industrial internship, but in the second year if you could take a research internship, you'll know whether it's right for you and what to do next, and it's more clearer for you. And usually in the second year, usually in any internship, in my internship at least, my main professor was Chandrasekhar sir, and I also had a mentor who was the PhD student of the professor. So day to day, I would talk to the mentor and get inputs from him, whereas weekly once I would meet with the professor and give my progress and tell him what to do next, what he's gonna give me advice and stuff like that. So yeah, go on. Next slide. Yeah, so the big question is, as an EC or EEE student, or basically any other branch, do I need to take a programming, and is it essential for me? Because a lot of people, they usually think that I would just go for a core domain, and like I'm referring to those who want to get placed after their graduation. So yeah, just go to the next slide. So yeah, by programming, I'm not referring to the coding aspects of electronic domain. So a lot of times you have to write code in HDL or in Python and MATLAB for some applications in the domain like DSD, digital system design. You have to write HDL code in languages like Verilog and DSDL, and then you have Python and MATLAB, which are very commonly used for signal processing applications. You also have Octave, which is like basically like MATLAB, and you have Arduino and other microcontrollers, and you have to write code for their working. And all of these are not basically programming per se, as I'm trying to say. And all of these are essential for that particular domain, and you have to learn them if you want to do a project in the domain. Go to the next slide. So when I say programming for EC people, I mean, do we have to learn the competitive programming type coding, and basically where you solve a problem given a set of constraints like your timing constraints and your space constraints, and skills like Yeah, continue, right?
Just a second. Yeah, you can go ahead, I think.
Yeah. So yeah, let me continue. When I say coding, I mean competitive coding type applications. And so, is it necessary for EC and EEE people to learn such skills? Is it important? So the unfortunate reality is that if you want to go to the industry and work in core-related aspects like electronics or even communication for that matter, there are very less opportunities in India, at least in India. So what happens is at least 50% of people in EC and EEE end up getting placed in software related jobs. So I feel like by the time placement season rolls in, people end up having to learn these skills anyway because of compulsion, or because after the internship season people end up realizing that they have to learn coding because they don't have enough opportunities. Even if you are good in correlated aspects, since there are not enough seats available, you don't, not seats, like if there are not enough job opportunities available, you won't end up getting placed or getting an internship in that field. So I say that it's at least mandatory for most of us to check out this competitive coding programming in platforms like LeetCode, Intervibit, Geeks for Geeks. So a lot of times people don't even try to look at it because they think that coding is not for them. So I feel at least people should just have a look at it and see if it's for them. And if they like it, obviously they have to continue pursuing this, because it is extremely important as far as getting placed in software companies goes, which in the end most people uh, end up with the job anyway. So I would say that CPA is something that people should look at. Go for the next one. So yeah, third year internships. So as far as third year internships go, you have industrial internships and research again. And the only difference is in industrial internships, you have a campus internship drive. It's organized by the CDC, and it's basically the same time as a placement drive, because the companies that come to get students for placement, they also take interns who are third years when they take it, but they intern after the third year. So on campus, you basically do the internship season, and off campus again, similar as second year, you cold mail HRs or some other people in the company. And the research internships, I think it is better covered by Diksha. It is basically you can apply for Indian institutions as well as abroad. And abroad, you have many different programs like MyTax, DARD, Viterbi, etc. And also, a lot of people cold mail professors even abroad and have very good success getting accepted. So people should look at all these options. The next one. The next slide. Good. Sorry. Yeah. No, sorry. The previous one. Okay. Yeah, so the internship season, as I mentioned, is by the CDC, and it starts at the onset of fifth semester, basically around the first week of August or July, depends upon when semester starts. And you have like around 2 weeks after you start when the first companies come to take the online test. So as far as electronics core companies go, there are something called as a big four, where most preferred companies are Nvidia, Qualcomm, Samsung, and Texas. So Samsung Semiconductor is not the same as Samsung R&D. So it's like a different division of Samsung, which works mainly on electronics and VLSI based domains. Whereas Samsung R&D, it works on other software based profiles. And one more thing that you can notice here is that almost all of the electronics based companies also have a software role. Some of them have pure software roles, whereas others do end up working on some electronics based aspects, but it has a little different profile as far as the hardware role goes. But again, in these software roles, programming and DSA knowledge matters a lot. And don't worry, they're just not four companies. There are also more companies like NXP Semiconductors, Global Foundries, etc. So usually these are the companies that are highly sought out as far as core companies go. But again, I want to reiterate that there are very less opportunities in India for core based profiles. So that's the reality. Next slide. So how is the procedure for selection during internships, and similar for placements as well? So the CGPA cutoff, when you apply, you have a cutoff in IRIS itself. You apply, and before the company comes, they have a portal in IRIS where you apply, and usually around 7.5 is the cutoff for most companies. There are some exceptions like Nvidia, which had a cutoff of 9 GPA for our batch, and 8.5 I think for the junior batch which came this year. And resume-based shortlisting. So some companies, again, similar to Nvidia is one company where the shortlist people based on resume. So even if you apply, you won't get to write the online tests or whatever the next round is, because they shortlist you based on your resume. So they take only the candidates that they think are ideal for the job. And then you have the online test where I'll talk about online test in the next slide. So it's like basically it's not the company coming into the campus. You just have an online test. They give you a portal and you basically answer some questions based on the profile that they are offering. And then you have technical interviews. This is probably the most important one and the one with which you have the most control of. I feel the online test is usually harder compared to technical interviews and also more random. Technical interviews where you sit and you make sure that the interviewer knows that you're capable for the job. And so it's mainly focused on your projects and other concepts related to your profile, and make sure that the projects that you mentioned are really done by you and you have worked on it and you know exactly what's happening, and all the related concepts of projects are extremely important. And obviously in the end you have something called an HR interview where the HR of the company basically talks to you about your ideas of what you want to do after like 5 years, and whether you have any plans for MS and so on. Basically trying to make sure that you are fit for the job. The next one. To the next slide.
Is the slide not visible?
Sorry. Yeah. So the online test. So the online test is basically having aptitude MCQs. Sometimes, like in Qualcomm, we had aptitude MCQs. So the MCQs are based on analytical thinking, verbal reasoning, etc. So there's a websites online, mainly IndiaBix, and it's pretty simple actually. It's more about applying your IQ and basically answering a lot of questions, which most of you will be able to answer, I feel. And speed is the key here. And then you have technical MCQs, basically concepts of digital electronics and analog electronics. You have circuit analysis as well. And sometimes we have questions related to Verilog or VHDL, which I feel people after second year, that is third years, they are not very sure of a lot of times. But I feel if you can, or if you have an opportunity to learn these languages, it's very essential to learn them. And then you have sometimes in some companies we have C programming MCQs. Qualcomm had it again. So basically syntax-based questions of C programming language, MCQs itself. And then sometimes you have programming rounds for software roles mainly, not for hardware roles. So as I said, even the hardware companies have software roles, and they have a programming round where you're given questions and you have to solve them given constraints. They're basically CP type questions. Good. Next one. Okay. So my experience from the interviews and my takeaways from this was that they basically focus on the understanding of the subject, not too complex questions, very basic questions. For example, in my interview, I was asked about the K map. So some of you might know what a K map is, a Carnot map. So they were asked exactly why is a K map used and why do they use 00011110 and not normal experience, normal numbers. So they ask very basic questions and they just test whether you know what you're working on, and then the projects are the most important ones, I feel, because the normal questions you might or might not know. They don't expect you to know everything, but if you blabber on your projects and you're not sure on what your own projects are, that's when they really think that you don't know much about the projects and you might have bluffed your projects. So it's very important to never bluff your projects, and also even if you have done the project, it's very important to make sure that you have revised everything about it and the related concepts as well. And then yeah, communication skills. So you should make sure that even if you know a lot of things, you should make sure that you tell the interviewer exactly what's going on in your mind. So that's very important during your internship as well as placement interviews. And the resume should be concise and sharp, and it should be telling exactly what you wanted to convey, and you should make sure that you only highlight the projects that are essential for that particular domain. So if you go for a software interview, you should not put only hardware projects and stuff like that. So that's very simple. And yeah, a longer resume is necessarily a better resume. So quantity is not the important thing, quality is the most important thing. Next. So my internship experience, I interned at Samsung Semiconductor, And unfortunately, thanks to COVID, this was a virtual internship. This was May to June of this year. And I worked in the System LSI division, RF analog team. Actually, the team and the division is not your choice. So once you get an internship, when you before the start of the internship, they look at your resume and they assign you the team and the work you're going to do. And my domain of work was real estate and analog design, even though I had a resume and my work was fully on digital electronics. But I took it as a challenge and I really like the work. And after this, I have been exploring a bit of analog design as well. So a lot of times you might have gone for a role that is mentioned, but you don't get the same role. That doesn't matter. It's always important to keep your head, uh, make sure that you have an open mind and work on whatever is given to you. And my work was on simulating differential ring voltage control oscillators. So oscillator is a circuit that generates periodic waves, and they are very commonly used in PLLs. Okay, I'm not sure that everyone knows about these things, but yeah, basically I was assigned to generate simulating these circuits for given set of frequencies. So we had to make sure that our oscillators were properly working in these range of frequencies and having a good tuning range. The next one. So the placement season. So what happened with me was my internship ended in June, but since this year was very haphazard and companies were not sure of how many people to take and stuff, Samsung ended up not really giving their PPO offer. So if you're not sure what PPO means, PPO is pre-placement offer. So when people intern in companies, if the company likes your work as well as if they have openings in the position, they give you an offer even before it's for placements. So that's a PPO offer. So a lot of interns are hopeful of getting a PPO offer. What happened is that we were waiting for the Samsung PPO offer, but they kept delaying it. They never told us that we didn't get it, but they kept delaying it. Usually, what the CDC ensures is that we get our PPO offers, at least get to know the status of them before the placement season starts, so we'll know what to do. So what happened in our case, unfortunately, was we didn't get our offers soon enough, and the placement season started. So in my case, what happened is Qualcomm was the company that I applied to in the placement season, and I got placed even before my PPO offer came. So my PPO offer was anyway null and void. So I would say that I've even seen cases where people have done very well in the internships. Their managers are very happy and they've told them that I'm recommending you for the PPO. But unfortunately, the HR tells that you don't have an opening in that role, so I can't give you an offer there. So even after your internship, people need to continue to prepare for the placement season because it might not go exactly as you wish. So it's always a good thing to prepare for it. So as far as the placement season goes, again, 7 semester, it's the same time as internship season. The same companies usually come and they offer they take both interns and employees. And so it's similar to the internship procedure. Only thing is they have more interview rounds, obviously, because now they're taking students directly for employee roles, FTEs. That's what they call it, full-time employees. And as far as core placements go, what I felt was VLSI design. It's a course usually offered in 5th or 6th semester. I feel for us it is offered in the 6th semester, and these concepts are extremely important during your placement season because a lot of companies have roles which require VLSI knowledge, and also they assume that students in their 4th years are proficient in VLSI. So VLSI design is something that I would urge everyone to look for if they are interested in a core placement. And your 3rd year internship project plays a huge role in your internships. So basically, when you're highlighting projects in your resume, you make sure to highlight the ones which are more important, like your internship project. So you have done a internship by your own. That is good. That I'm not saying that. But when you're interning under a company or under a professor, you have a validation from the particular organization or the professor. So 3rd year internship project plays a huge role. So even if you do not have an internship in 3rd year, I would say that people usually end up working on a project on their own to make sure that they have better credentials. And so it's not the end if you don't have an internship in 3rd year. You can always prepare well for the placement season, and you have a lot of time on your hand to prepare well for the placement season and do well in the placement season. Next slide. So my placement, I got this Qualcomm, I just told you, and the procedure was similar to the internship. The placement procedure was basically online test, and then C programming MCQs and electronics MCQs, technical MCQs, And then there are 2 technical rounds of interviews. I had both of them for 1 hour each. So there were there's one interviewer in each technical round. The interviewers were very nice, and they were very encouraging as far as whenever the questions were asked. So even if you're not sure of some questions, they're giving you hints or making sure that you don't feel very stressed. So as far as as far as interviews go, it's important to make sure that you believe in yourself and you don't feel dejected if something does not go your way. So a lot of times, what happens is that people. Uh, what happened? Okay. So what happens is that people, even though they're deserving, they end up not getting some particular company or some particular role that they wanted, because a lot of times random things happen. But it's important to make sure that you keep your calm and you keep working, and because in the end it all works out. That's what I feel. And again, the HR round, they ask you basic questions like, why don't you want to go for MS? Especially if you have a good GPA, people keep asking, why don't you want to go to MS? So companies are actually scared that students will ditch the company after 2 years and then go for MS. So since I didn't have any plans for MS in the near future, I was pretty honest about it. But most of the times, you should not be too frank about it, because if you tell them I'm going for an MS after 1 year, there's a good chance they won't offer you the job. So the position that I've been placed in, associate engineer. So people from BTech are offered this position in Qualcomm. The next slide. So general tips for internship or placement seasons. So yeah, as I said, they can be very long and stressful. People end up thinking that they're good for nothing. That's not true. Just getting an internship does make you feel great, and someone's telling you that, look, you're good enough to work for us. That's a really good thing. And that does not mean that if you don't get an internship, you're not good. A lot of times, as I said, you might be deserving of the role, but you don't get it. So you have to keep working and looking for different opportunities and never feel bogged down. And a huge advantage for EC and EEE students is that all software companies are open for us, almost all of them. So when you have companies coming onto the campus, before you can apply for the company, you need to be your branch needs to be allowed by the company. So a lot of times companies do not allow branches like mechanical, civil, and metallurgy or other non-circuit branches, unfortunately. But an advantage for EC and EEE students is that all software companies allow almost all software companies allow our branch. So you should make sure that you can take advantage of this and maybe look up some software related aspects, because in the placement season, if all the core companies just finish taking students and you're not one of them, it will be too much to take, because it's too late to prepare for something. So it's always good to start preparing for it. At least not prepare for it, at least explore these fields in your first and second year, so that you'll know that this can be a viable option for your future. So the third thing is check out the internship and placement gear. So Iris, we have this something called as CDC. There's an option called CDC. There's something called placement gear. So people write about the experiences of their internship season, placement season, as well as their internship as well, the internship itself. So I think you can get information about my batch, my seniors batch, as well as 3-4 batches of your seniors. So that's a very handy information to know, and you'll get to know exactly what you need to do for each company or each specific domain, and that will be extremely useful for you guys. And this is basically the general tips that I would like to offer. Next one. Yeah, so that's my insight on basically my experiences over the last 3 years. And yeah, thanks a lot. There's a question, right?
Yeah, thank you so much, Rohit. We have one question from Akash Huda. What is the scope of combining VLSI and signal processing domains in the research field?
As far as I know, there haven't been a lot of projects in where they combine VLSI as well as signal processing. But I guess it's something that people can think of. Especially if you're a first or second year, you can approach professors in EC department. A lot of them work on signal processing, and they also have a VLSI knowledge. So if you approach professors and discuss your ideas, they will definitely be very supportive of you and probably work on a project with you. So always, if you think of something, you should always look it up, look at the previous work done in that field, and try to do a project on the field, where a project always really helps to understand a lot of specific things in the field, just that a particular course or a lecture can't. So yeah, that's what I would say.
I think that's the last question. Yeah, so thank you so much for sharing your experiences and information, especially about how to apply for internships and placements and how to prepare for it. So thank you so much, Rohit.
Thanks a lot.
For our final speaker, we have Manas Sharma. Manas, are you online?
I am online.
Yeah. Okay. Sorry. Just a quick introduction. Manas Sharma is from the Information and Technology Department at NITK. He's the co-founder of OxyHeal and is also the captain at NITK Racing Electric, a subsystem of the electronic subsystem within NITK Racing, and he's currently placed at Ford Motors. So, Manas, I'll let you share your experiences.
Yeah. Is my screen visible?
Yeah.
All right. Fine. Fine. So my topic for today's talk is following interests. I think a lot of people talked about career opportunities and everything. So I'd like to make it a bit lighthearted and let's talk about interest. So coming to me, first of all, as mentioned by the host earlier, I am Manish, and I am final year undergraduate from NIT Surat IT department, and I have done a lot of things apart from IT department than in IT department. So let's get to that. So first of all, I like electronics quite a lot. Like electronics is my day and night, all the time. So I would like to talk a bit about where did this passion for electronics came for, and I'll just get you give you a bit of idea about how it affected my future right now. So I started learning basic electronics in my quite early, I think around fifth standard or sixth standard or something. Like I by sixth standard, I think I knew soldering and other stuff, basic stuff of electronics. Then I used to love experimenting with a lot of stuff. Like I used to randomly get something, open it up, see what is inside, look at, okay, fine, what is this thing component? I'll just check the component, read the number, Google it, find it out what exactly it is. So it was just a geeky head trying to figure out what exactly is happening in a lot of places, and that actually does help a lot in terms of learning. Then from there again, I learned, and I still do self learn a lot. So usually, because I am not related to electronics department or anything as such, I learned most of the things by myself through for electronics. And after that, from I think seventh or eighth grade onwards, I was participating in a lot of competitions which were related to development and stuff like that. And I think in 11th standard we founded a robotics club at school. That is something pretty ambitious for a school, and we did that. And after that, when I joined my college, my first club that I joined was NIT racing, and then the experimentation kept carrying on. Now coming to electronics, so electronics itself is a very vast field. So I think you can always have some sort of starting point for you to start understanding how things work and how to implement certain things. Now in terms of experiment, see, if you are not exactly from circuit branch, I think getting structured exposure to electronics is kind of difficult at times, and usually internet is your best friend. You can almost find everything about everything on internet, and that's how usually I learn most of my things. I'll talk a bit about the electronic journey further in my college next. So as you can see in my college life, I chose pretty diverse disciplines like Oxyl, which is my startup. Apart from that, NIT Racing Electric, which was the electric racing team that I started in the college. I was part of NIT Racing Combustion Vehicle team. I was part of IRIS Media, and I was also part of IEEE Piston. So pretty diverse, and again not related much to my branch as such. Coming to individually at so just to, I think the talk has been going on for quite a long time, so I'll just to give you guys a bit of action, I would share a small video from an ITK racing CV combustion vehicle. So this is one of the video as what we did. We during our testing times in night. I think so. So that was one such occasion when we usually have fun at night. So in general, in our campus, I rarely stayed at my room. Like I used to always be in either racing team's lab or somewhere else, like working on something or the other. At least that was the situation from my second year onwards. First year, I tried to explore a lot. I participated in a lot of workshops. People mentioned over in the previous talks that we had Arduino workshop, we had Node MCU workshop, we had a workshop from Texas Instrument. We had a lot of different things, and I used to, in general, like just go and explore, because in general, first year you have a lot of time to do stuff like this compared to your second and third year. So usually, like we use that opportunity quite a bit, and we used to just go and sit in some workshop or the other. Like so, full day we used to do that. And first year, and we joined an ITK racing. After summers, we actually started working on the car. And to be honest, like if you see the work that happens in all the clubs and the work that happens in racing teams, the work is quite substantial over there. The money that is involved is quite big over there. Like you can just imagine the project that we are working on is a car. The car costs, like for combustion vehicle, it costs like around 6 to 8 lakhs. That is the budget of the car. So the amount of money that is going in, the kind of technology or the kind of work that you're seeing in the car is huge. And that was the combustion vehicle. Now coming to the electric vehicle team, which we started like last year. The current situation is that, like for an electric vehicle, you need a sum of around 24-25 lakhs, and that's a lot of money. And so you can understand the kind of technology and the kind of work that was going into the club. So in general, I can say one thing, that first of all, these racing teams and these clubs, they are good point to start exploring new things and having a good understanding of the actual prototyping process and the actual design process of something real, rather than just reading the theory of everything. Because you get a lot of opportunities in these two particular clubs to actually build and try out a lot of different things which you might not be able to try out in normal clubs because of the budget restraint constrictions and other things. Coming to, apart from that, I was also interested in art and bit. So usually to give that also a chance, I just joined Iris Media. And over there also, like I think I worked for like almost like 2 years in Iris Media by now. And so that was like my getaway from like normal tech stuff, and usually Iris Media was that. Apart from that, third year I joined IEEE Princeton, because IEEE also was doing I was doing racing car projects and other things for almost like 2 years, and I was like, okay, fine, let's try out something else as well. And I joined IEEE Princeton. Over there also new projects, completely new field. We did two projects over there. We did a monocopter project, which was like rotating UAV, which could get a 360 view videos. So we worked on that, and apart from that, I'll come to my startup a bit later in this field. So in general, like what you need to make sure is, like first of all, when you enter the college, like don't restrict yourself. Try to figure out all the, like what clubs are there in the college, what they are doing, and try to at least try your hands on into everything, because every club will always have like some sort of uh, talk or induction program that is going on with them, and you can understand like what exactly work that goes on in that club. Like you might not have an understanding just by the name, say like ACM doesn't necessarily like translate to something like compared to flying a robotics club. But what kind of work that goes into that in that particular club will be defined again if when you go and attend the different workshops and other things of those clubs. Now coming to oxyheal. So yeah, this is something that was like very close to me. So we started up. I think after quite a long time, we are like one of the few startups in the college who are actually like progressing quite well right now. So how we started up. So in my third semester, the I came to know about a competition known as a Texas Instruments India Innovation Challenge and Design Contest. This is a big competition. It's carried on all over India, and it's a big and it's a year-long competition. The prize money was huge, and that was the first thing that attracted us towards this competition initially. Like we were like, okay, fine, it's a big competition. The prize money is like 20 lakhs. So let's just give it a try. And for that, in general, like as I told, I was always into building things and electronics before. So I was like, okay, it's a good opportunity to just try new things. And plus, it was a sponsored competition by Texas Instruments, so you get the components and a lot of components from Texas Instruments for free. Like you don't have to pay anything for that. So that was the one motivation that we got. Okay, fine, let's give it a try. And we started with this competition. We For the competition we had to look for some idea, and like in general I had a lot of ideas, but recently during that time I actually came across a video of a 14-year-old girl working on a wound management sensor. So basically it was a sensor that could define like measure various parameters in a chronic wound, and predict its healing time. Now you might ask, what is a chronic wound? A chronic wound is a wound that does not heal in like maybe 3 months or 6 months. So usually those wounds don't heal, and the end option is is to amputate the feet. I think a good example could be diabetic foot ulcer. I think a lot of people might be aware about that. Seeing someone like with diabetes get ulcers and wounds in their foot. So that was the kind of wound that we were talking about. And we came across the idea from like at least like we initially thought, okay, fine, we also work on something of similar type, more suited towards India. And we started working on that. We started talking to various doctors. Like, so we had a friend of mine who's had some contact in Ames, Delhi. So we talked to that guy. He gave us an insight. Okay, fine, why don't work on anything that is just for sake of monitoring a wound or something. India doesn't have a particularly good market for monitoring devices. So he told, work instead on something that could probably heal the device. And then he started giving us idea, and we kind of realized one thing, that medical and engineering usually don't have such good collaboration. Like because and because of that, like even very simple problems have not been solved very well in medical field. So he gave us our initial problem statement, as what we can say. And he told, like, you can probably, there's a hyperbaric oxygen therapy system that is available right now. Patients take that, and they have a lot of side effects and other things. And he told, like, okay, fine, if you can improve something on that. So I was like, okay, fine, why does that side effect happen and other things. He gave us like various different explanations for that. And then we came across, okay, fine, so it is pretty simple to solve. Like, it's a hyperbaric chamber in which the whole person is going, and he's uh, inhaling pure oxygen, and that is the reason why he's getting so many side effects. So why not just localize that therapy to his particular wound area? And that was a direction, and then we started working in that direction. uh, we worked for that like almost 8 months or something in that direction, working on a particular device that could do that. And unfortunately we were like eliminated in the semifinals of the TI India Innovation Challenge. And after that, we applied for IB Hub Startup School. IB Hub Startup School is a bootcamp program designed for people who are interested into entrepreneurship. It is a very ambitious program, as over I think 650 to 700 startups participate in the program, and only they select only I think 20 to 25 teams altogether. And the program is a month long. You are supposed to go in, stay in their place, either in Lucknow or in Hyderabad. And they provide all the fooding, eat, like stay, everything. They basically, it's a free of cost program. You just have to go over there and present yourself over there, and you get taught by best mentors around the world. And it's a pretty good program. and it's like an eye-opening program for anyone who is interested into entrepreneurship, because what we see around and what we like usually do, okay fine, like this is a problem, I face this particular problem, I will solve it because I think everyone must be the same problem, but that usually isn't the approach when you go with entrepreneurship. So we went to IBF's startup school. We got really good insights over there about how to improve our product, and we kind of realized that okay, fine, we actually by ourselves don't have a good understanding of our own product, and we kind of worked on that. And after that, they suggested us to get more people in the team who are from the medical field, and then we did recruitment, and we got 2 medical individuals on board from Father Muller Medical College in Bangalore. And after that, since then, like we have been bootstrapping our basically our product development by participating into various B plan competitions. The numbers, I think I don't even remember the number of competitions we have participated and won. And like recently, like 2 days back, we won 3 competitions. So like it's like that. So and after that, after almost working for 2.5 years, we got a grant from government of India, that is Nidhi Prayas grant, and it was worth 9.3 lakhs to support our product development. And right now we are working in the product development phase, and like probably by around a year or so we'll get into trials. And that's the particular reason why all of us opted for getting a job despite of working on a startup, because we are like, okay fine, even if we want to work on the startup right now, since we are in the product development phase and we are prototyping things, so let's just get a job as a backup, so that when later if you want to switch, we can just easily switch. So you can check us the details, more details about the product and the page at LinkedIn or at oxyl.co.in. Coming back to tips for first years. So the first years, first of all, I would like to ask all of you guys to, like, even if you are like you're thinking, okay, fine, I might be interested in this particular field or this particular field, please don't restrict yourself. Like first year, please just go on and explore everything, like literally everything. Like you might start finding things that you might have not thought ki mere ko pasand aayega. So you can try out like a lot of different things. First year, there are a lot of clubs that are there in the college, and I think don't join a lot of clubs. Join clubs, I think a bit, because otherwise it will be too hectic. In first year and second year, you usually don't feel the burden of the clubs, because first year, second year, usually there isn't a lot of work. But third year and finally is when the work starts piling up, and then the things get a bit hectic. Like at times I used to have like my breakfast recently, like I think 3 months or 4 months back, I used to have my breakfast at 6 or 7 o'clock, like continuously for 6-7 days at times, because I was involved in so many different things. So that could be a situation. So like choose the clubs that you are getting into wisely, and don't just put your hands into everything. Try to explore everything out, but without a commitment as such. That is what I would suggest. Apart from that, I'll get into the startup thing further. So tips to for starting up. So first of all, in college, I think it's pretty ambitious to start a company in college. So first of all, in order to like understand get an understanding of how to basically go about that, first of all you need to find out a problem statement. A problem statement, first of all, should be something that is worth solving. And how do you identify a problem statement is not by looking at, okay fine, I have issue with the shape of this particular mixer grinder and I want to make something new. That isn't exactly how you find a problem statement. You usually talk to people, connect to people, and like try to get feedback of the end users, and not in like a number, like maybe 2 or 3. Instead you could try to get a lot of feedback. Like I think like we did around 20-25 interviews of various doctors just to get an understanding of how the market works. Some feedback might be positive about your idea, some feedback might be negative, but in your having a lot of feedback does help a lot, and does help you like understanding and reinforcing the idea. After that, you need to understand if the problem is worth solving, because a lot of times you might see there's some problem. Okay, like okay fine, people might be comparing, okay fine, then why is this say a door handle of this particular shape, but are they really willing to pay for a new shape or for something new? So that is something you really need to understand. Like, is the problem really worth solving? Can you build a business out of it? So that is something, two things that are very important in terms of understanding, like at least even thinking of an idea for a startup. Third thing that is very important is whether you like to work on that idea or not. Like it might be possible that, okay, fine, you find a very important, like good problem statement, and you find, okay, fine, it's worth solving as well, but the thing is you don't have any expertise or any knowledge in that field. So that could also be a hindrance in terms of getting your startup going. Second thing is find a good team. A lot of times what happens in college startups is like you end up making a team of your friends, and that usually isn't the most optimal way of building a startup team that will function down the line. Because usually, as you might remember in your school, you had a lot of friends. As you progress in your college, you'll see certain friends get left behind, and there are certain group of friends that are left around. Again, then in those friends, like you'll have like again different skill sets that are required. So like in a startup, you need someone who can handle the product. If it is a product, someone who can handle the service if it is a service based startup. And then you need someone who can handle the operations, because the operations is quite a big of work in startup. Then you need someone who can work on fundraising. Then you need someone who can like actually has good skills of marketing and other things. So these are like a lot of the various skill sets that are required in a startup. And like usually when you go with like say group of like-minded people, you end up getting all tech people or all marketing people or operations people. So usually it's good idea to think thoroughly about your team when you're actually serious about getting a startup going. Third is like again developing a product and getting a product market fit. That is something really important. So what exactly is meant by product market fit? So say I like say for my example, my oxygen. So we work on a wound care device. Now the wound care market itself is pretty big, but it's not really viable as a company to target the whole market, despite the size of the market being very big. You can make a lot of money if you go in the whole thing, but the thing is you won't be able to go in the whole thing, because that will require a lot more funds. And again, bigger market without any establishment is a problem. So usually you tend to find a customer segment, a segment of people whom you will target initially, and you usually add up to that eventually in the time, and your company grows according to that. And most importantly, get into the journey early. If you guys are interested in entrepreneurship, try it out some things, fail early, again try it out. Like that's the whole way of going about it. Like even if we are right now at the stage, we can say one thing, like, so in my team, like I have 3 people, like 4 people who understand ki we want to do a startup, we are a good fit together. And even if this particular startup doesn't work out very well, we can work together again for something else down the line, down in future, because like we have a good balance of everything that is there in the team. So this was pretty much, I think. So yeah. So where can you contact me? I'm available on LinkedIn and WhatsApp. Please do not call me. You can text me. I think I'll reply to that. And I think I'm open to questions right now.
Thank you so much, Manesh. I had a question for you. The question is, so like when you have a startup idea in mind, there is besides the engineering aspects, there are also certain economic aspects. So where did you get help from, or how did you learn to manage that part? Do you have any tips on that side?
See, depends on what exactly you're getting into in terms of startup. Like if it is a product based startup, like again you need a lot of money initially to lot of money to like at least develop the product. So that is in a product based startup. In a service based startup, usually that's not the case. Like you can do the hard work yourself. You need not say like it's a event management startup. You need not hire 10 people and get them working. You can do it yourself as well, like initially at the initial stage. That's how usually again it's very specific to different startup, but in general, like you should keep in mind you need finances only when, like you should raise money only when you need it. First of all, that is very important. Like even for a competition or even for a grant or anything, if we did not need that 9.3 lakhs, we wouldn't have just gone behind the money and raised it. Because the thing is, having money in hand doesn't help. Usually it ends up either being there in your account and not being spent, or it will just get spent around here and there. So usually that's not a good approach. Like, just think about it now. Like, I would need to make a proof of concept. What is the amount of money I need for that? So usually you list out all the activities that are required to get to that particular level. Now say for simple app based startup, so say for app, say you want to buy a license framework. Now you buy a license framework, that is the cost that is adding. Now say you want to you are good at certain things and you want certain things to be outsourced, so you add those costs. And in general, like, that's how you it's a very structured way of forming a key how much my budget should be for every particular activity in my startup. And then those activities in general, you add up to all those activities and you get an estimate of how much you need throughout the year. Like, so for this year we knew we need around 15 lakhs or something ish. So 9.3 lakhs came from the grant, and like other we are working on it right now through competition and other thing. So that was one approach. In terms of finance and operations, again, it's more of talking to people and getting connections. It's not like just straightforward कि ऐसा कुछ operation का एक procedure होता है. There's nothing as such. Usually what ends up happening is you get a lot of calls, you have to attend calls, you have to attend meets, you have to talk to people. There are a lot of vendors out there. You take the feedback, you implement that usually, and the operation people usually will have to maintain. Because initially you might think we do, so first year in a startup we didn't have a lot of work. Okay, like we used to be like, okay fine, now what, ab kya karna hai? But eventually what happened, like at this point right now, is like we almost put like 4 hours or 5 hours individually, everyone. And I put because I'm working on the product development, I put almost like around 10-12 hours every day on just on the startup. So that's how much the time that goes. Like, so initially you won't have a lot of work, but don't underestimate that. Eventually you'll get there.
Okay, thank you. And Akash Huda has a question. How did you find out about the various competitions? So what are your sources?
So which exactly competition are you talking about? Like a product building competition or the VPN competitions? Can you just answer that? If it is a product building competition, I think there are a lot of hackathons that keep happening around. I think that would be a good starting point for those competitions. And in terms of B-plan competitions, Dare to Compete is what we refer to. So Dare to Compete is a website where a lot of other colleges and other like bodies put up their competitions and other things in one place, and you can literally look for that. Okay, fine, this is the competition, this is the date, this is the requirement of the competition, number of team members, and
Okay.
There's what you can do to promote and support startups, I think. So we had a lot of issues with the college. That's why we don't involve college a lot with our startups initially. Like, some people had success, some people didn't. So again, it's, I don't know, like exactly, I don't have a good answer to that, because we didn't get a lot of support. And I think that's kind of related to individuals in the college rather than the whole college itself. Because college is not very clear about a lot of things in terms of startup. Like, some people told us, making a startup in college is illegal, which was not true. Some people, and these people were profs from college, so they were like, having a startup is illegal. Then we had a patent for our startup. Then they were like, certain profs were like, okay fine, having a patent on your name while being in college is illegal. I'm like, dude, again, fine. So that there's a lot of misinformation. First of all, like, college should be more clear about what is their stance on the startups, because without that, students won't approach them, because there's no clear body. There is a step that is there existing in the college, but again, not much does happen in, like, people don't know a lot about what is there in step, and again, step doesn't approach startups individually a lot. So that communication gap is there in between college. I think that needs to be fixed first before even doing anything else.
Okay, thank you, Manish. And you have a really diverse set of experiences, starting from Oxy Hill to Iris and then NITK Racing. So it was wonderful listening to you.
Thanks a lot.
So I think that he was the last speaker of the day. Yeah, there are no more questions. So I think we've come to the end of today's event. So today's Insight, today was the first day of Insight, and we had the Diode SIG hosting it. So all the speakers were related to electronics, electrical, or communication backgrounds. This event is will also continue for today, tomorrow, and day after tomorrow. We'll have Piston and ComSoc, the core and computer science branches, having their sessions. So do attend that as well. And I want to thank all the 5 speakers for sharing their experiences. It was really it was wonderful to listen to all your experiences, and I'm sure the viewers agree too. And thanks for everyone who attended this talk and asked questions as well. Thank you for joining us. I think that brings us to the end. So good night.
Is the live stream over?